Hi everyone, in this video you have to show the given function in the two parts will be a constant function, but first you have to revise these three statements. If f prime of x is positive, which means greater than 0, then f of x is increasing. If f prime of x equal to 0 in a given interval, then the function of x will be constant in the given interval. If f prime of x is negative or less than 0, this means the function of x is decreasing in the given interval. So we will interested in this statement. When f prime of x on a given interval equal to 0, this means the function of x will be constant in this interval. So in part A, you have to show that the inverse sine of x plus the inverse cosine of x equals pi over 2. So you have to prove that this function equals c, which is a constant. Then you have to find that the value of this function equals pi over 2. First, you have to check the continuity of the function. So the function f of x equals sine inverse of x plus cosine inverse of x. This function is continuous on the interval from -1 to 1 because the domain of cosine, the inverse sine and the inverse cosine is from -1 and 1. So it is continuous by the definition of the domain of these two functions. So it will be continuous from -1 to 1. Secondly, you have to check the differentiability of the function. So you have to find f prime of x. So f prime of x equals the derivative of the inverse sine of x, which is equals 1 over square root of 1 minus x squared, plus the derivative of the inverse cosine of x, which is -1 over square root of 1 minus x squared. And this is equal to 0, which means that f is differentiable on the open interval from -1 to 1. Now, since the function is continuous and differentiable in the given interval, and f prime of x equal to 0 for all x in the interval from -1 to 1, this means by this statement that the function f is constant. So inverse sine x plus inverse cosine x equals c. It is a constant in the given interval. So sine inverse of x plus cosine inverse of x equal c. Now you have to find this c, and you have to check c equals the right hand side here, which is pi over 2. How to check that? You have to take a point or an x value inside the interval. Let's say x equals 0. Now you have to find f of 0, which is the inverse sine of 0 plus the inverse cosine of 0. Now the inverse sine of 0 is 0, and the inverse cosine of 0 is pi over 2, and 0 plus pi over 2 is pi over 2. So this constant is pi over 2. So this is the proof of part A. You have to check the continuity, you have to check the differentiability, then you have to check that since f prime of x equals 0 for all x in the given interval, this means that f of x is constant in this interval. Then you have to find the constant by plugging a value inside the interval from -1 to 1 in the given function. And that's it for part A. Now in part B, you have to show that if f and g are functions for which f prime of x equals g of x and g prime of x equals to -x, for all x, then f squared of x plus g squared of x is a constant. So you have to prove that the derivative of this function is 0. First, you have to check the continuity and differentiability of the given function. So the function we have is f squared of x plus g squared of x. This function is continuous since f prime exists and g prime exists for all x. So this function is continuous everywhere from the given conditions and the question. Secondly, you have to check the differentiability. Now f prime equals g from the question and g prime equals negative f for all x, and this means that the function f squared plus g squared differentiable everywhere. So the function continuous and differentiable everywhere. Then you have to find the derivative of the function f squared of x plus g squared of x, and we can write it as f of x all the quantity squared plus g of x squared. And you have to use the chain rule to find the derivative. So the derivative of the first term, which is f prime of x squared, you have to put down the exponent 2. So we have 2 times f of x multiplied by the derivative of the inside function, which is f prime of x plus the derivative of the second function. So you have to put the power 2 down multiplied by g of x power 1 multiplied by the derivative of the inside function, which is g prime of x. Now from the question we have that f prime of x equals to g of x. So we have 2 f of x multiplied by g of x plus 2 times g of x multiplied by g prime of x, and from the question g prime is negative f of x. So we have minus f of x. So we have 2fg minus 2gf, and this is equal to 0. So the derivative of the given function is equals to 0, and if the function equal to 0 for all x, this means that the function is a constant. So f squared of x plus g squared of x is a constant function. So the main idea in the two parts is if we have a function continuous and differentiable on an interval or everywhere, and the derivative of this function equal to 0, this means that this function will be a constant in the given interval. And that's it. Thank you, and thank you for your watching.